Alright, this is 5.3, graphing using y equals mx plus b. So the perimeter of a rectangle is 42. So the perimeter, and in a little bit I'm going to explain why I wrote out all of that. The length of the rectangle, so length equals x plus 4, and the width equals 2x minus 7. What are the dimensions of the rectangle in centimeters? So we have done a lot of these with area, but this one's a perimeter. Which perimeter of a rectangle is 2L plus 2P. 2W. So, or I could do L plus W plus W. That's okay. Some people draw it. So this is 2x minus 7, 2x minus 7. Now, some of you forget to write it on all four sides, so be careful with that. So I'm going to do it with the two lengths, so x plus 4, plus 2 w's, 2x minus 7, distribute 2x plus 8, plus 4x minus 14. Combine those x's for 6x, and 8 minus 14 is negative 6. My perimeter was 42, so 42 equals 6x minus 6. So I'm going to come over here to work that because I didn't leave myself much room. This should be a nice review to what we've already done. Divide both sides by 6, and I get the x equals 8. That's not what my question asked. It asked what's the length and width. So I'm going to plug in my 8 here. So 8 plus 4 is 12. So my length is 12, which only matches D, but I want to check my width out also. 2 times 8 is 16 minus 7, which is 9, which matches D. Alright, if you have any questions about that, just send me an email. That's the best way to do it. Recall the slope-intercept form of a line. Y equals mx plus b, where m is my move, my slope, while b is my y-intercept, where I'm going to begin. So I'm going to look at the line, graph the line, y equals x. So let's think about that. So I want the form y equals mx plus b. But all I have is y equals x. So we've talked about this many times, but if I can say pencil, or I can say 1 pencil. So this could be x, or it could be 1x. And what could I add to that where it won't change the value at all? I'm going to add 0. So my y-intercept is 0, and my slope is 1, which I'm going to change to 1 over 1. So I have a rise and a run. Alright, so I want you to box or highlight, if you have a highlighter, this important message here, because this is going to become important as we go on. Alright, so important. This is the most basic linear function. It's also known as the linear parent functions. So as you go along in algebra, different graphs are going to be parent functions. And from there, we're going to see the movements of graphs based off of that parent function. Let's go ahead and graph it. So we're going to start at a 0. That is what we call a direct variation because it goes right through the origin. We're going to rise 1, run 1, rise 1, run 1. And we're going to keep going. Go a little bit both ways. You can go the whole way if you want, but I do recommend you doing quite a few, and then you can connect it. Again, as I said in the last video, you can use a ruler or the edge of a binder, or I'm using, as you can see, an index card because it's a little raised. So there's our graph. Let's look at our next one. So our graph is in the form y equals mx plus b. So we have our y equals -3/2 x minus 3. So my m is the -3/2. The b is the -3. I can tell you now it's going to be decreasing because my slope is a negative slope, which means it's going to be going down. So we're going to start at -3. That's our beginning. And we're going to rise -3. So 1, 2, 3, run 2. Now the reason we went down is because remember negative means going down. 1, 2, 3, 1, 2. Work a couple of them backwards. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 2, 3, 1, 2. And you know you've done it right. When I line them up, it will make a straight line without anything. And the way I line up and do such good graphs is I start at my top point, make sure it's against that line. And I look at my bottom point, make sure it's against that line. And then connect. Alright, so that's the graphing. Let's go to the back side. So y equals mx plus b. So we have y equals -4x. So my plus b here will be a plus 0. So my y-intercept is 0. My m is -4, but I'm going to go ahead and put it in fraction form also, so I have that rise and run. It's going to be a decrease because it has a negative slope. So we're going to start at 0, meaning that it's proportional, that it is a direct variation. We learned that word last year in 8th grade math. So I'm going to go down 4, 1, 2, 3, 4, and over 1. Down 4, 1, 2, 3, 4, and over 1. Then I'm going to work it backwards. Up 4, over 1. Up 4, over 1. And graphing usually is better with mechanical pencil because you can be a lot more accurate. So line up my top dot, line up my bottom dot, and draw a line through it. Alright, let's look at the next one. Y equals mx plus b. We have y equals 1.2x minus 4. So my m is 1.2, and my b is -4. Now I know that it's going to be increasing because that is a positive slope. So in class I'm going to be asking students, what do we see different about that m? Hopefully you're recognizing it's a fraction. So I'm going to have 1.2, which is 1 2/10. But again, does that give me my rise and run? It gives me a rise and run, but what about that 1? So I need to make it improper. So we're going to do 10 times 1, which is 10, plus 2, which is 12. So 12 over 10. 12 over 10, which will simplify to 6/5. So that slope is 6/5. Alright, so I'm going to begin at -4. I'm going to rise 6. 1, 2, 3, 4, 5, 6, and run 5. Now you'll notice the bigger my numerator and denominator are, the less points I'm going to be able to fit on my graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let's see if I have enough to go the other way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. It is important to have quite a few points because it does help you draw a straighter line. It helps you see a full picture. I have people sometimes who do this. Okay, that's not good enough. I want the whole, I want the graph to fill up the, I want your graph to fill up your coordinate plane. Ooh, that was horrible. Sorry. So be sure you fill it up pretty decent. Sorry that line is horrible. The edge of my index card's kind of getting worn out. Alright, let's look at the last one. Graph the line that contains the point 0, 6 with a slope of -3. So if I go to 0, 6, 0, 1, 2, 3, 4, 5, 6, that's my y-intercept. So my y-intercept is 6. And then a slope of -3 is the same as -3 over 1. So 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And I'm going to keep going to fill up my graph. Now, honestly, you may have, I'll get a new index card. You may have teachers in the future who don't care if you fill up, do your dots all the way. I'm honest, I don't know how our high school is, but it's how I was taught to do it, how I've always done it. I think it gives you a good picture of what the graph really looks like when you extend it all the way out. Later on, you're going to look at some x-intercepts, so you're definitely going to want to see it cross both axes. There we go. So my equation is going to be y equals m, which is -3, x plus b, which is 6. And it is a decreasing because it has a negative slope. All right, so I want to encourage you again, if you aren't able to print this out, either A, send me an email so I can get you a copy of these papers today, or you should have probably gotten them with lesson 5.2, or get some graph paper and graph these for your notes, and for the homework on 5.3, you're really going to need some graph paper. Get it again. Just let me know if you need graph paper, but you need to stay on top of your work. All right. If you have any questions, please email me. Please let me know. Sorry, that's 5.4. Just let me know. I know doing it remote's not always the best, but hopefully you're understanding. Y'all have a good day. God bless.